Ever wish you had a personal financial consultant working 24/7, making perfect, emotionless investment decisions? Trillions are lost yearly due to emotional trading and slow analysis. Today, we're using AI agents to fix that. We're building your 24/7 financial robot, an AI investment agent in Python. Let's code it. The problem is information overload and human emotion. Our solution is the AI agent. Our agent solves this by operating purely on logic and data. Simply put, it's software that perceives its environment, decides an action, and then acts to achieve a goal. The agent's workflow uses machine learning for the core decide step and an LLM to enhance perception. We start the perception layer by getting numerical features, dual MAs and a new one, volatility using yfinance and pandas. First, we'll establish the project environment. For this project, I'm using Python version 3.11.9. Since we are using PyTorch, I'll begin by installing that framework, followed by all remaining dependencies defined in our requirements. Let's explore the project structure files related to the perception phase, where the agent gathers and processes all the information it needs to make a decision. Configuration settings.py defines the stock ticker, timeframes, and required feature list. Data acquisition, dataloader.py downloads and cleanse the raw stock price history. Feature processing, feature engineering.py calculates technical indicators like moving averages and volatility. The second part of perception is LLM Sentiment. We use a transformers pipeline to turn aggregated news text into a numerical sentiment score. External data capture, sentimentanalyzer.py, queries the LLM API to get real-time market sentiment. All right, we've gathered all the data in the perception phase. Now let's go to the next phase, decide. To train the brain, we first define the target, success. We label a day a buy if the price increases by 1% over the next 5 days. Financialagent.py contains the main function to train the model's brain. This is the true AI brain. We're using a random forest classifier to decide. It learns the complex relationship between our MAs, volatility, and the LLM sentiment score. Random forest classifier.pkl. This file is the trained and saved machine learning brain. Our model learns and outputs its accuracy score. This tells us how well the AI can decide the best action. If you're finding this deep dive into AI agents fascinating, hit that like button and subscribe helps me create more content like this. Now for the act phase. financialagent.py. It contains the act on signal function that gathers the latest data, runs the model's prediction, and formats the final trade recommendation. We feed the trained model the latest data, including the latest LLM sentiment, and ask it to predict the future. Orchestrator, main.py, the main entry point. It controls the overall flow, deciding whether to train the AI brain, decide, or execute a trading signal, act. Let's run the code. Our agent instantly analyzed years of data and issued its final action signal, executing a precise rule triggered when the fast line crosses the slow line. Quick reality check, our agent's perception improved, but decisions still rely on limited data and simple models. No risk management yet, and features are basic. Note, this code is educational, not financial advice. With care, we can add real-time trading, LM explanations, and smarter tools like LSTM and sentiment analysis. Step 1 complete. We built our first AI agent using ML and an LLM. Now I want your ideas. What AI agent should we build next? Project management, personalized health planning, or something else? Comment below. If this video opened your eyes to the power of AI agents, share it with a friend, and don't forget to subscribe for more advanced AI tutorials. Thanks for watching, and I'll see you in the next build.